going to be introducing the topic of the circulatory system. And we are an introductory biology class, either 9th or 10th grade. And I want to start off with a little review of what you might have learned in middle school or some of your past experiences. So, veins and arteries, we've all heard of these words, and I want you guys to just talk with the people at your table about what you know about veins and arteries. And you can cheat and look at the diagram if you would like, but go ahead and talk. Would anyone like to share what they discussed at their tables with the rest of the class? Heard some good things over here. What did you say?
Arteries carry oxygenated blood, and veins carry deoxygenated blood.
Very good. And how about the direction? You see those arrows up there. Where would the heart be in that diagram? Mitch?
The heart would be on top of the artery.
On top of the artery. Very good. So up above. Because veins carry blood towards the heart and arteries carry it away. And an easy way to remember this is arteries and OA both start with A. Yeah.
So the arteries have a lot thicker walls because probably more muscle to get it away from the heart.
Good. Yes, that's true. How about the vein up there? What does that have that the artery does not have? Yeah, Dr. Cook.
It's got vein or valve.
It does. The vein has a valve. And how can we remember that, class? V. They both start with V. So yeah, the valve is what regulates the blood flow in the vein. And as Becca was saying, in the artery, they do not have the valves. So how do we think that the flow is regulated? If you need blood somewhere quickly, what is going to happen to your arteries? Becca kind of mentioned it already. Yeah.
They close up so the blood has to move faster.
Right, they close up with muscles either surrounding or even in the wall there. It'll contract. Muscles could push from anywhere in your body if it needs to get the blood moving. So very good. All right, so that was just a little review. Now today, we're going to focus on that heart, okay, because that's the core of the circulatory system. So for the question of the day, I want you guys to guess or estimate how many times you think your heart beats. Talk with your table if you need some help trying to figure that out.
I'm going to do the math.
Just have a few seconds.
Is it 1 per second, roughly?
Well, if
All right, we heard 3,600.
about 75 times 60.
A minute?
What does everyone
Times
else
60.
think over here?
Times 24.
Yeah.
And so 60 times 24.
I used to do this
You're a
in
lot of good math
60
going on.
times 60 times 24, or 75 times 60 times 24.
Hours into a day.
Okay, why seconds?
Usually, I guess if you take your pulse, you're measuring in 60-second intervals.
Okay, so, or a minute. So if you counted how many in a minute, yep, and then converted that into hours. So you'd be doing some multiplication there. How did you set it up? Did you write anything down? Anyone else? Anyone can answer. Yeah?
Dimensional analysis.
Whoa, big work, math words. We're in science now. So what did you do? What'd you multiply?
I just put we did there's approximately 70 beats per minute.
Okay.
And then times 60 minutes per hour, and then 24 hours per day.
And what'd you come up with?
100800.
So we're going to learn today the different parts of the heart. So looking up at this diagram, we can see the blood flow, and I also put a list of all the parts of the heart we're going to talk about. And I wanted to start right at the top with the right atrium. Has anyone learned about this in other courses and happens to know off the top of their head where the right atrium is located? Raise your hand if you do. Becca, would you want to point that out up there on the screen?
I think it's right here.
Very good. That is where the right atrium is. So by default, where do we think the left atrium is? The opposite side, right there. Okay. So those are two of the chambers of the heart. Then we have the ventricles. And where do you think those are? You can just yell it out if you don't want to get up. The bottom half, yep. So they are these bigger compartments below. So the right side
Blood
and the
moving
left
down
side. And then out through the right atrium down into the right ventricle and then back up. So, and in this case, it's moving down from the atrium into the left ventricle and out. So how do we remember that? We could go with some of the same ideas using letters. Okay, A comes before V, so we're going to move from A to V with the blood flow direction. The next word up there is aorta. Does anyone know anything about that? It's the main area or vessel that receives the pump of the heart. So all the blood from the left ventricle, after it comes from the left atrium, gets pushed up into the aorta. And then you can see the arrows that are going up, which is going to go, where do you think those will lead in the body? Brain?
Yeah, to your head, like up to your head.
Up to your head, yeah, the upper body. And then hiding down at the bottom is the red arrow, and that's, can't see it, but it's going all the way down, and that goes to the lower portion of your body. So that pump is the most important for being strong, because it needs to send blood to your entire body, all your extremities. And so that aorta is thick because the blood that's getting pushed in there is going to be pushing on those walls hard. So not only is it thick, it's also flexible because it has to absorb that massive amount of blood that's getting pumped every time. Pulmonary artery and pulmonary veins. Do you guys know what the word pulmonary means? I see you pointing to your chest, right? The lungs. So pulmonary just means referring to the lungs. Something to have to do with the lungs is what you should remember if you ever see the word pulmonary. And we already discussed the difference between artery and veins. So looking up at that picture, we see there's a little word over there that says left lung, and those are the arteries and veins. So which one here would be the artery and which one would be the vein? The red and the blue. The artery is the blue, and the vein is the red. Does that make sense? Because we have the arteries going away from the heart, and then the veins bring it back. So the artery goes out to the lung, because it's the pulmonary artery, gets oxygenated, and then once it comes back through the pulmonary vein back to the heart to oxygenate the heart.
Why is the aorta red then? I mean, is it oxygenated?
Yeah, the aorta is oxygenated because right after it comes in from the lungs here through the pulmonary veins, it was just oxygenated, comes through here, and then shoots out to the rest of the body. Superior vena cava, okay, that vena is like vein, so it's a vein. Where do you suppose the inferior vena cava is?
Bottom.
The bottom, yep, you got it. So you are familiar with the terms superior and inferior, so that one's pretty easy to remember too. Superior is up above, inferior is down below, and since these are veins, where is it taking the blood? To the heart, very good. So you can see those arrows, they're a little bit covered up, but that blood is coming back from the upper body and the lower body, coming back into that heart. Good. Did you guys have any questions about that? It's a lot of terms there. Yeah, Mark.
Why do they always use red and blue colors to do the circulatory system?
That is a great question. We're going to talk about that right now. So we've already kind of mentioned that one means oxygenated and one is deoxygenated. And I think people already told me. Do you know, Mark?
Well, I think if it's deoxygenated, it actually is blue colored. And blood that's rich in oxygen is actually red colored.
Yeah.
But then, if that's true, then how come when you get cut, you bleed red and you're cutting veins that are near the surface of the skin?
You bleed red because what's in the air?
Oxygen.
Awesome. There we go. So that's the easy way to remember which is which in these diagrams. That's usually how it should be. If they switch it up on you, you better be observant and make sure you notice, because it's possible. You can't trust that always red will mean oxygen and always blue will not. So yeah, we covered how you'll remember that. Okay, so we said blue blood. How does the blue blood become red? How does the deoxygenated or less oxygenated blood become red or oxygenated? So this, we have a big picture of a lung here. You can stand to the side. So we discussed that this is the right ventricle is going to pump it from the heart into the lung, okay? Because that's just come from the body, the lower body, upper body, and it needs more oxygen because we've used it up. So it's going to move into the lung and come in down here. What are these? Yep, and the way bottom are the alveoli, okay? Those are little air sacs. That's the end of our lungs, the smallest part. And when this blood passes by, just magically becomes oxygenated, right? No. How is this happening? Why is this happening when it reaches this point down here? Does anyone know? Think way back to lessons about diffusion. What do you know about diffusion? Simple diffusion. There's no pumps here because oxygen is a gas. So it's diffusing. Why is it?
Oxygen is able to flow into the cell.
It's flowing into the little capillaries and like the veins and arteries. The capillaries are the smallest part. We forgot to discuss that. But when it's the smallest type of blood vessel is a capillary. And the oxygen is able to flow through that capillary and hit the blood. But why? Why would it want to?
Is it the O word?
It says hemoglobin.
Hemoglobin? Those are,
It wants the oxygen.
it wants the oxygen. And what else do we know when we think about diffusion? Think of concentration. Yeah, high to low. So we've just inhaled. Everyone can inhale. So your lungs are full of oxygen down here. This blood is passing by. So because the oxygen's high here in your lung and this blood that's coming through is low, it's going to diffuse in and move back into the heart, fully oxygenated, and then out to the rest of the body.
So is that osmosis or no?
Osmosis, what does osmosis have to deal with?
Change in concentration from one through a membrane?
In water, usually, I think, we refer to osmosis. Diffusion is a type of, or osmosis is a type of diffusion when we refer to water and solutes. Here we're talking about blood. Osmosis, I think, is specifically with water. Does anyone have anything else to add to that you know?
Is that right?
Good question, yeah.
Right?
Worth looking into more. So that's passive diffusion up there. The high concentration of oxygen is moving in to the low. And now, if you guys don't have any further questions, we're going to move into our lab activity, label the parts of the heart that we talked about.
So veins are going to the heart, right?
If you have
So-
questions, raise your hand.
Yes, veins are going to the heart unless it's a pulmonary vein.
Exactly, which we just found out.
Yeah.
Okay. So now this is coming, so
So if you were going to dissect something and look for veins, you couldn't find them because they'd turn red the minute that they got oxygen from the air.
although if it's arterial blood, it'd be a bright red.
Yeah.
Like arterial
Yeah.
injuries. Okay.
Dark red, yeah. Real dark red.
Or bright red.
Yeah.
Yeah.
Yeah, well.
Add the arrows and indicate. Okay, what label the diagram using the word.
Okay, right atrium.
Up here.
Yeah, this is right atrium, left atrium, right ventricle, left ventricle.
Okay, so right atrium. I'm just gonna put that.
You were in the heart, following yourself through the flow of the heart throughout the body, or it could be also a homework assignment. Do you have any questions?